Hi, dear students. This short video is about some complementary things on dimensioning. First I'm going to talk about inspection dimensions, and then, whole coordinate tables. Okay, inspection stage may take a very long period of time, especially if the object has lots of features to check in size and to their locations. Although there are lots of entities to check whether during the manufacturing stage the size of those have been set correctly in the range bounded by upper lower limits. But say that inspection time which is allowed is relatively very short. Especially in such a case, the object is not only one in number. There is a party, a load, and in the load there are, let's say, in the order of 100 or even 1000 identical components. Okay, and at the inspection stage, each of them is to check whether their size are correct, location dimensions are correct, as they are shown on the technical drawing sheet. Of course, there is no doubt the inspection room is capped at the standard energy level. It is energy level is to be 20 degrees Celsius. And then, measure the size and location dimensions. But you have not only one component, lots of components for doing this, for checking their size. In the basket you have 1000 objects. These are the same objects in shape and to the order of magnitude. But say before marketing them, as the quality control inspection department, they are to be checked. If the time allowed for inspection stage is very limited, then we use statistics. First make a sampling from the load, select statistically, randomly select some components. For instance, reduce via which the number of components to check from 1000, for instance, to 100. Okay, 100 components may represent the load. Okay, we reduce the number of components to check in size, but it is still too much. Then okay, in such a case, that is the solution. If the inspection time is not sufficient to check the size of all the entities, then select or specify some dimensions, the dimensions of some entities. Okay, and define them as inspection features, inspection size. Their size going to be inspection size, inspection dimension. Of course, it is fixed by the designer. Designers doing such a thing, identifying the entities as inspection entities. Commonly they select the functional entities. And not all the functional entities, but at least some of the functional entities are defined as inspection entities, and their dimensions are highlighted, saying that these are inspection dimensions. Such a case, instead of being keen on measuring the size of all the features, only the size of the inspection entities are checked. inspection dimensions are checked. Okay, and well, in case the inspection time is short, so well, only by measuring the size of inspection features can finish the work. Okay, now after bringing such a scenario, such a case in the scenario, then we'll answer the question, how about the format to use to inform the others that the dimension is an inspection dimension? Okay, well, example. In the example, yes, we have some functional dimensions. Normally, in most of the cases, well, functional dimensions, at least some of the functional dimensions, are also defined as inspection dimensions. Okay. Well, we do not define the non-functional ones as inspection dimension because non-functional feature going to be in contact with a fluid. Its size is not so critical, but functional dimensions are important. Well, say that time is very limited and not large enough to inspect all the dimensions. Well, specify some of them as a must to check at the inspection stage. For instance, this dimension have already been shown. Okay, it had to be, let's say, specified as inspection dimension. If it has been forgotten to highlight that it is an inspection dimension, well, you know, in general, a dimension can be edited in case. How? Bring the cursor onto the dimension and double click. It is to take the dimension into edit mode. And after taking the dimension into edit mode, well, select inspection dimension tab in the dialog box and then, well, take a right to specify the dimension as inspection. How? Making a click into this little box. And then, well, we have two alternative formats to use to highlight that dimension is an inspection dimension, this or that. Well, in this format, you see, well, the dimension now is within a special box. It is a box with rounded ends. To its appearance, such a box looks like the box that is used in informing the others that it is well, a datum dimension, it is a box dimension, it is a dimension related with the geometrical tolerances. It looks like. So it may cause to misreadings. Although there is such a format, it is not recommended by me. Select the other format, making a click onto this radio button. Now use this special box to inform the others that it is an inspection dimension. Okay. Well, although we specified some dimensions as inspection dimensions, and these are to check at the inspection stage, but if say the worst case, worst scenario, time is still not sufficient, although, well, even to measure such inspection dimensions, then in that case we can use the percentage. Well, into this box, writing the percentage inspection rate, say that 80% of the dimensions of the 80% of the sampled ones are to checked. Then into this box, write a percentage value. Okay, I think it is clear. Now, whenever you see such a special box, it is for the dimension, of course, dimension has been shown within such a special box, then sure that it is an inspection dimension, and at the inspection stage it must be checked. Okay, I think this is clear. The other thing, well, dear students, to highlight is about whole tables. Now, there is an example here. Well, normally well, the whole table, well, in the common format or representation is used if there is a pattern of holes. Not one hole, not two holes, but more holes we have. These are just, well, the members of the same family array. Well, in the pattern, of course, if there are few holes, then, well, it is not so time consuming thing, and also, well, the space to have for showing them not so much, so, well, can use the general dimensioning format. Okay, well, show the location dimensions first with respect to the body of the object, and then with respect to the with respect to each other, with respect to one hole, show the location dimension of the other. Well, the offset distance between the members of the family, show this location dimension. Okay, show this location dimension, and so on. Okay, well, if there are few holes, then why not use the general dimensioning format? Show the location dimension, and also, well, size dimension. For instance, well, indicate one of them, yes, of the family, right click, and then say okay, and then, well, edit it. Well, bring the cursor to the beginning of this printing and say the dimension shown for this one is not valid only for the indicated one, but valid for the others. In the family, in this example, there are 4 identical holes. So, in accordance with ISO, write the number of identical elements and then put a cross, and then write the size of one of them. Then yes, it is to say that not only for the indicated, but you know the meaning of this annotation. 4 identical holes, it is a pattern, the dimension is the same, and these are the location dimensions. Okay, this is the general format. The alternative format, of course, it is a practice or common thing if there is a family of holes, pattern of holes. Okay, well, then assume, although it is not, we have not 4 holes, but say that 50 or 100 or more holes around this projection. So, well, space is not sufficient to show all the location dimensions, and also even the diameters. Then, well, can do what? In answering the question, first delete this size and location dimensions, okay, between the members of the family. Only show the location dimension for one of them, for the first coming one, and then, well, clicked on this option, whole view tab, and then, well, indicate the view. After starting the process, it is to have a table, okay, about the size and the location dimensions of the hole in the end. Indicate the view on which we have the edges of the holes. Indicate that view, and then you see cursor is in a different appearance. It is just center symbol. Well, locate this symbol to the center of one of the members. It is going to be the reference member, okay, and the coordinates of the others going to be measured and show with respect to this reference. Locate it with a click, and then yes, following stage, you can see the frame of the table. Find a suitable empty space on the page and then locate it. Yes, you see, Inventor identified the holes using this codes A1, A2, A3, A4, and then, well, in the table along the first column we have the ID letters, ID codes of the holes. Along the other column we have the location dimensions between the successive holes, okay, and in the y direction, x direction 69. Yeah, well, check from here, the center to center distance is 69. Okay, and in the y direction it is 62. And along the last column, yes, you can see the specs of the hole, diameter, and whether it is truly extending hole or contour bore hole or spot faced hole. You can see. Yes, either show the location dimensions, but whenever the space is not sufficiently large to show the dimensions around the image, then well, prepare such a hole table. Keep in mind, this is also in practice quite common. Okay, dear students, well, as I said, this video record just to hear me on such complementary things. It is short enough. Okay, then that's all. Ending the record. See you later. It is me, Associate Professor Dr. Murat Sönmez from Middle East Technical University Northern Cyprus campus, Mechanical Engineering program. Bye bye.